Electric blue sunsets, presented by Science at NASA. Northern summer is underway. It's time for picnics, hot dogs, dips in the pool, and, oh yes, electric blue sunsets. Just below the Arctic Circle, evening skies are filling with pale blue ripples. They appear just after sunset or just before sunrise and are called noctilucent clouds or NLCs. When viewed from space, the same atmospheric phenomenon is referred to as polar mesospheric clouds, or PMCs. Cora Randall, chair of the Department of Atmospheric and Oceanic Sciences at the University of Colorado, says the 2016 season for noctilucent clouds began on May 24th, when NASA's Aronomy of Ice in the Mesosphere Satellite, or AIM, spotted a puff of electric blue around the Arctic Circle. NLCs are Earth's highest clouds. Seeded by meteoroids, they float at the edge of space more than 50 miles above the planet's surface. The clouds are very cold and filled with tiny ice crystals. Those tiny crystals do a good job of scattering blue light from the rising or setting sun, hence their electric blue color. Noctilucent clouds appear during summer because, ironically, that is the only time the upper atmosphere at high latitudes is cold enough to crystallize molecules of water around specks of meteor dust. The role of meteor dust in forming NLCs is one of many discoveries made by AIM, which NASA launched in 2007 to study the mysterious clouds. James Russell, principal investigator for AIM at Hampton University, says, "These clouds continue to reveal intimate details about how the atmosphere works. Each season yields new information." The first recorded observations of noctilucent clouds were made in the 19th century after the eruption of supervolcano Krakatoa. At the time, people thought the clouds were caused by the eruption, but long after Krakatoa's ash settled, the clouds remained. In those days, NLCs were a polar phenomenon confined mainly to the Arctic. In recent years, they have intensified and spread with sightings as far south as Colorado and Kansas. The reason may be climate change on the edge of space. A recent study by AIM's science team member Mark Hervig and colleagues, published March 2016 in the Journal of Geophysical Research, confirms that the mesosphere, the atmospheric layer where NLCs form, has gotten colder and moister in recent decades. Both trends promote the formation of NLCs. Their results are consistent with a simple model linking the clouds to two greenhouse gases. First, carbon dioxide promotes NLCs by making the mesosphere colder. While increasing carbon dioxide warms the surface of the Earth, those same molecules cool the upper atmosphere, a yin-yang relationship long known to climate scientists. Second, methane promotes the clouds by adding moisture to the mesosphere because methane oxidizes into water as it rises in the atmosphere. Noctilucent clouds appear to be a telltale sign of important greenhouse gases, and that, says Russell, is a great reason to study them. They may be at the edge of space, but they're telling us something very important about our own planet. For more news from the edge of space, stay tuned to science.nasa.gov.